Here I'm wanting to just take a look at your assignment for this week. This is your assignment. This is a Google Doc that you can take a look at and actually type your answers into it as we go. So for instance, you'll be able to just type your answers down into here, and you can do that for each of the questions. For this assignment, you're going to go to this particular website, and yes, I want you using this particular website for this one. It's the same website I used before, but then it was just one of the options. Now I actually want you using this one in particular. And on that site, you're going to scroll down and pick one of these three different graphs and sets of data. And you can choose whichever one you like. Any of them will work because they're all basically exponential. They're fairly clear graphs in order to be able to work with. And that's what we're going to do is we're going to be writing an exponential equation for this. For writing your exponential equation, I'm actually giving you the variables to use. So yes, please use these. So instead of y, I want you using a. A is going to represent the amount of confirmed infections. The amount of confirmed cases basically there. And then T is going to be the time. Now notice specifically I'm telling you that T is going to be measured here in days. And so make sure that you are using that for days as we go. So you're going to need to go and pick one of these three graphs. So you go over to the site, and I'm choosing to use this graph, which is the total cases outside of China. And for doing this work, you're going to need some numbers to actually use. And that doesn't mean that I want you just looking at the graph and estimating about what it is, but you can actually get exact numbers by moving your mouse over the graph. And you'll notice that as you move your cursor over the graph, it's telling you that on a given date, there were a certain number of cases. And that's the numbers that you're going to use. Now, you're going to need to pick two of those. Now, I wouldn't just automatically use like the first one, because you notice it changes quite dramatically there at the start. And so that might not necessarily be your best data, but you can if you want to. And I wouldn't necessarily use the last one, although again, you are certainly welcome to do so. But you're going to pick any two of those points. Write down the date, and then write out how many cases there were on that date. And then you're going to be writing an equation. In order to do that, the first thing you're going to need to know is what date is time zero. So for instance, are you going to use January 22nd as the first date, as time zero, just because that's the first one on here? Or are you going to use, let's say you use this point as your data. Perhaps you would decide to use that as time zero. You can do that. That can be a choice for you. Or maybe you want to make your life a little bit easier and you just want to say, well, I'm going to make day zero to be January 1st. So the first day of the year is the first day. You know, you can do stuff like that. It's up to you. It's a personal choice thing. Nothing is any more right or wrong than anything else in terms of that. All right, then I want you to tell me what the 2 points are that you're using. So actually write them as coordinate pairs. So like x comma y, in this case t comma a, for both of those, so I can see what your 2 points are. And then you'll write your exponential equation going through those 2 points using the lesson that we went through this week. And then once you've written your equation for number 3, then you can go on to number 4. Because then you're going to say, how many cases would you predict there to be 1 week from now? So in other words, that's after where we are today, going 7 days later. So you're going to have to add 7 to whatever that day is. And then you're going to plug that into your equation that you came up with back in part 3 and tell me what that number is. One of the reasons I want you doing that is because then here in a week, you'll actually be able to check and see how accurate was your model. You'll actually be able to see, is that going to be pretty accurate? Then I want you to figure out how many cases you would expect there to be 30 days from now. And then how many would you expect there to be 1 year from now? That is 365 days from now. And that number will probably be particularly interesting. And I want you really thinking about that number as you are doing number 7, because in number 7, it then gives you a chance to reflect on the equation and the numbers you're getting out of it. How accurate do you think the equation is going to be for modeling the number of future cases? And so it's a matter of thinking through that whole process and thinking about, okay, what do you think it was going to be? Do you think this is going to continue? Do you think it's not going to continue in the same way? How might it change, if at all? Think through a lot of those little details about the real world context. Really, number 7 is a real world context kind of question for you to be able to delve into that.